All right, problem number 1.
Use the greatest common factor and distributive property to rewrite 63 plus 15.
All right. What's the first thing we need to do to write the distributive property?
Find the greatest common factor.
All right, find the greatest common factor. So we have 63 and we have 15. Okay? I'm going to use what method to solve this? All right, ladder method. Okay? Who can think of a common factor between 63 and 15?
3.
Okay. All right, definitely 3. Okay. How many times will 3 go into 63?
21.
All right, 21 times. And how many times will 3 go into 15?
5.
5 times. Okay. Do 21 and 5 have a common factor?
They both are.
That doesn't mean that they don't have anything in common.
No, because 3
have one. They both have one.
They don't have.
They don't have number 1 in common.
They only have the factor 1 in common. So is our ladder complete?
Yeah.
Okay, so then what is the greatest common factor of 63 and 15?
3.
All right. Who can describe the distributive property? Well, if we want to write the distributive property, how would we write it? All right, Quentin. How are we going to write the distributive property? Just speak.
3, write it?
Just talk.
3 parentheses 21 plus 5, then parentheses.
Okay, now what does the parentheses mean? What should he have said?
You add them together.
3 times, okay. 3 times what?
Numbers in your
21 plus 5. Very good. Very good. Check it to make sure your answer is correct. If it is incorrect, you should be making adjustments to your work. Put the distributive property on there. Okay, how can I check this answer?
You gotta check it by first. You gotta add 2. You gotta add 63 plus 15 up, and then you got to multiply 3 times 21.
All right, 3 times 21. What's that give us? 63. And 3 times 5? 15. Okay. Did we get our addition problem back out of the distributive property?
Yeah.
Okay, so we can say that our answer is more than likely correct. All right, this concludes problem number 1. Let's move on to number 2. Go ahead.
Nigel and Rob collects rocks. Rocks have the total mass of 53 and 2 grams more than Nigels. Altogether, their rocks have a mass of 342 and 5 grams. How many grams of rock does Rob have?
Okay, how can we figure out how many grams of rock Rob has?
Subtraction.
All right, subtraction. Very good. Subtraction. We know the total amount together, and we know how much his friend had. So in order to figure out what's missing, we can do what? Subtract, okay? You see what 2 numbers are we subtracting?
Minus 53.2.
53. What do we do? What's the important thing to do when you're subtracting decimals? Line up the decimals. Okay. You don't have it, you need to make corrections. Okay, another thing with subtraction is you always want to make sure the larger number is on top. All right, 5 minus 2?
3.
3 minus 2?
You gotta go to your place.
Okay, we'll regroup by borrowing from where?
10's place. The 4 and the 10's place.
The 4. Okay, 4 becomes 3. And the 2 becomes what? 12. Very good. 12 minus 3?
9.
5 minus 3?
So you gotta go to your place. You gotta borrow from. You gotta borrow from the 3.
Okay, 3 becomes what? 2. And the 3 becomes what?
13.
13. Very good. 13 minus 5.
8.
And 2 minus 0.
2.
Okay, make sure you line up your decimal.
No.
So how many rocks does Rob have?
289.3.
289 and 3 tenths. So if you write your sentence should state that Rob has 289 and 3 tenths rocks. Okay? Make sure that you made any corrections that you needed to make to your homework. Okay. All right, problem number 3.
The large roller coaster takes 7 minutes from start to finish, while the small roller coaster only takes 5 minutes from start to finish. If both roller coasters start at 9 a.m., when is the next time they will start at the same time?
Okay, stop right there. All right. What type of problem is number 3? All right.